The next speaker is Ulrich Eberle. He was part of the project the whole time, responsible for important part project 1. And Ulrich is a diploma physics doctor, yeah, and he works for Stellantis. Yeah, I forgot because we all know each other. Works for Stellantis and as project manager for innovation and a project lead for advanced technology. We had a very good time. Stage is yours.
Thanks a lot. Yeah. Dear ladies and gentlemen, also a warm welcome from my side. And you did it already, but I have to reiterate a little bit. We would like to thank the German Ministry for the Economic Affairs and Climate Action very much, because this ministry funded PEGASUS family projects very generously over nearly a decade. And without the support of the German government, this project would not be possible. Thank you very much, and especially to you, Mr. Stöckel-Puckal, because your involvement was very decisive in these projects. I would like now to talk a little bit about the context from foundations to future work, to give you a little bit a big picture why PEGASUS VVM was needed and what still could be done, what is still necessary. Okay, why PEGASUS and PEGASUS family? My predecessors already talked a little bit. We want to go from SAE Level 2 systems to SAE Level 3, 4, and 5, and the first Level 3 systems are now on the market. What's the main difference between a SAE Level 2 system and 3, 4, and 5, of course? Most of you know that, of course. The object and event detection response is transferred. The real responsibility of driving is now taken away from the driver and given to the automated driving system. And therefore, this responsibility needs to be validated and proven. And also in the sense of the safety of the intended functionality, and also a concept will play a very important role today. And tomorrow we will discuss a lot about it, about operating domains and operating design domain. Yeah, we are talking about automated driving. Automated driving is an old dream. Automated driving is nearly as old a dream as the automobile itself. There are nice newspaper reports from nearly 100 years ago, Roland, by the way, from Dresdner Tagesanzeiger, that there is cars running around without, be careful, without a man at the wheel. That's not acceptable today anymore, this wording, but the dream of remote operating and automatically driving a car is extremely old. Challenges remain 100 years later. We have the traditional distance-based approach, and the distance-based approach requires a lot of driving. If you consider the average German driver, with some simple statistics, you can calculate that you would need about 6 billion kilometers of driving to prove that you are as safe as the average driver. And 6 billion kilometers, that's a quite abstract number, but to give you a comparison, 6 billion kilometers corresponds to 16,000 times the distance to the moon, 40 times the distance to Mars, and 40 times the distance to the sun. And as we all know, 50 years later, after Apollo 11, we are still struggling to get humanity back to the moon with the Artemis programs, 16,000 times the distance between Earth and the moon. We did it about 20 times, I would say, already. Still a way to go. Therefore, we need a new approach, and this new approach was initiated and proposed by our original PEGASUS project, and it's called scenario-based testing. And this means that we are trying to reduce the test effort to the relevant scenarios, and we are also trying to get to tackle the open world problem, because what is sometimes not so clearly communicated is that automated driving is not only a complex problem challenge, it's also an open world challenge. Anything can happen, especially in urban. And therefore, we need virtual testing as an additional crucial pillar. And by virtual testing, we do not only mean that it's simulation, but the virtual testing will also, that means that also hardware involved stuff like hardware in the loop or vehicle in the loop testing, hybrid reality will play an immense role in our future work program. And as you see, this is was proposed by the original PEGASUS project, and we could not accomplish our mission completely of the now 5 years ago, and therefore the German Ministry of Economic Affairs and Climate Action agreed to fund 2 further projects, VV methods, and set level 4 to 5. I'm very happy that a lot of colleagues from set level are also here today. We also have an exhibition booth which will tackle or present results from the simulation efforts of set level 4 to 5, and hopefully there might be also potential future projects within the PEGASUS project family. Why are we standing here? What is the reason for VVM? And the reason is clearly that PEGASUS, original PEGASUS, focused on the highway chauffeur. And there's still a lot of work beyond highway driving. Of course, there is also a lot of work still remaining for highway driving, but for VVM and set level, we wanted to go a little bit further to focus on urban. You see it here, the OD is extended to the urban environment, and the knowledge and requirements analysis is refined. The regularity and legal aspects are tackled, addressed in way more detail, and also the test distribution and the orchestration is there's much more focus on that in comparison to the original PEGASUS project, and that shall lead to a coherent overall methodology and to a coherent safety argumentation. And also we intensified a little bit our international cooperation. That also was very important from the very beginning, and we were also encouraged by German government to do it. But you see it, especially tomorrow, we have a lot of guests from Japan, from US, from France, and from many other countries. I've seen a lot of guests from Korea will join us tomorrow, and therefore you see a real PEGASUS and VVM. This is really an international appeal. We feel honored, but also a little bit proud on that. For example, on the scenario databases, we had some exchange with a French project called ADScene and the UK project Safety Pool, which are working especially on this type of databases. Okay, what's the main difference beyond just changing the ODD from highway driving to urban? The original PEGASUS project focused mostly on the right-hand side of the V model. What you see here behind me is a little more complex version of the V model. We have used a 6-layer model and a set of logical scenarios, and we are also it is a main result of the original PEGASUS to introduce and to disseminate the concept of logical, functional, and concrete scenarios. And but there remain some blank spaces you see on the left-hand side. On the right-hand side, you see our new VVM approach, and my dear colleague Helmut Schittenhelm will explain it to you in detail. But the main point is that we now try to wrap our methodology around the complete V, and to use the scenario-based methodology also for the verification and validation, for the behavior specification and the risk evaluation. Okay, then let's talk a little bit how we try to do that. First of all, we want to ask the right questions on criticality, benchmarks, and targets. Asking the right questions is always very important to get the problem solved, because if you do not ask the right questions, you are merely lost. Second, we need to master complexity, and especially the parameter space explosion. I just mentioned that we would need 6 billion kilometers of driving in the classical concept, but in scenario-based testing, we have a challenge. This is called parameter space explosion, and that leads to a huge number of scenarios that would be needed to be tested, and therefore we have a related problem that needs to be tackled. As I mentioned before, driving in an urban environment is the point, and we are trying to solve it through decomposition, traceability, and reasoning. What do we mean by reasoning? We do not want to test each single concrete possible scenario, but we try to have a logical reasoning to deduce what could happen and to try to cope with the complexity by doing so. And finally, simulation is not all. Simulation is highly important, and simulation plays a bigger and bigger role and is merged with classical methods, but for that we need also a highly sophisticated approach for test distribution, orchestration, and also for analysis. Because we produce a huge amount of data, we need a huge amount of data, but we also need to be capable of analyzing a huge amount of data. And it all condenses down to this overarching challenge: how do we cope with the open world? Yeah, you see it here on the slide, the VVM project goals. We want to map an infinite number of possible scenarios to a finite number of scenarios that can be handled. And how to choose them, how to come up with them, this is goal one. Also to map infinity to a finite set of logical scenarios. That's a huge challenge. I'm not sure whether we really solve the problem completely, but at least this is the target. Then we have a high need for consistent interfaces, technical interfaces, methodological interfaces, also interfaces with regulators. There's a lot of stuff to be done to work on a nomenclature that everyone understands. All that needs to be worked on. Then I talked a lot already on the shift to simulation, therefore I will keep that a little bit short, but you see it here, the seamless integration of the use of virtual and real methods. And finally, argumentation. This is what I just meant with this reasoning. How to get to the conclusion that we are safe. As my predecessors already mentioned, we need safety. This is a prerequisite of introducing this technology on the public roads. Okay, and safety is more than technology. Most of us are engineers, but we need to be aware that we have to cope with different things. We have, of course, within the scope of VVM, functional safety. We have also the safety of the intended functionality, but we need to care about laws and regulations, and also somehow we also need to convince the public. We need to convince the society that and our fellow Germans, Europeans, citizens of the world, that automated driving is a reasonable technology that is really helping our societies and also us as individuals. And by doing so, we introduce the concept of the absence of unreasonable risk. And on these concepts, I would like to recommend a talk by my dear colleague Thomas Kirschbaum, which will present virtually today on this topic. This is a very interesting talk. Okay, again, let's reiterate. We had PEGASUS, and now we have VVM. What's the difference? Yeah? Also, as you see here, the classic approach would be brute force, just driving around. The PEGASUS approach was introducing an operating domain and selecting an operating design domain and try to cover with concrete test cases as much as possible as you can of this operating design domain. That's quite difficult because we have the challenge of parameter space explosion. And therefore, VVM tried a further refinement of our scenario-based methodology. We want to introduce the concept of argumentation. We do not want to argue with anyone. We want to convince the people. And by this argumentation concept, we mean that we have a logical concept that if a certain scenario or test case is safe, that we can say that related test cases and test scenarios are also safe. This is a complex strategy, and I hope we can convince you of the concept, and perhaps not only, it's also very challenging to explain it if you are not first exposed to it, but we try our very best to explain it to you in these 2 days. Okay, then operating design domain, I just mentioned. We will discuss a lot about operating domain and operating design domain. What we are trying to do with VVM is that we have the world. The world is more or less the operating domain. And we want to operate our automated driving system safely, and this subset of the operating domain where we can operate safely, this is the operating design domain. And what we are now trying to do is we want to, similar to in physics and mathematics, we want to do something similar as what is known as linear independence. We want to use so-called core scenarios which are related to the concept of linear independence, and by using these core scenarios, we want to cover the operating design domain. And these core scenarios, this is not something completely new. These are logical scenarios, and we try to structure the parameter space with these scenarios. And this is what my colleague Helmut Schittenhelm from Mercedes-Benz will try to explain to you later in detail. It's also a tough job, but I'm quite optimistic we will manage to convince you from these concepts. Okay, how are we structuring these things? In original PEGASUS project, we introduced 6 layers, and this PEGASUS 6 layers are also used. I called it here 6 layers to structure them all, to structure the OD, to structure the ODD. And in this project, we developed also some new formats, a data format called Omega and an ontology called Auto, which are based on the 6-layer model, but go a step further and try us to help and understand the scenarios of the ODD. Okay, and the ODD, or better the OD, is the world. We need an actor, and the actor is the automated driving function. In the context of PEGASUS VVM, we call this the customer function. Also to emphasize that the customer function is the actor operating in the world, and we tried in VVM to keep the actor as independent of the world. Also the world poses the challenges, and the ADS system tries to solve these challenges. Why is that important? Because you have different type of automated driving systems. You have perhaps volume manufacturers with less sophisticated sensor suite compared to a perfect world sensor suite. I would like to mention the colleagues from Karlsruhe University and their sensor suite over there. This is the other extreme, but these actors, these different actors, they must cope with the challenges of their operating design domain. And therefore, we tried to to visualize it here, so we have our world, the operating domain, and then we start engineering with an initial operating design domain. The initial operating design domain is connected to the initial requirements of the customer function and with the initial software and hardware of the automated driving system. Of course, while developing, there are refinements. Therefore, we have work in progress. Then we need to refine the ODD, and this refined ODD is again connected to the refined customer function and to the refined software and hardware of the ADS. Because you always have two strategies. You can also, if while development work, you see new challenges, you can restrict ODD, or you can try to cope with additional technology. And finally, at the end, we have the final operating design domain and a final customer function and the final hardware and software. And this is very important to us. After these refinement cycles, the system needs to be safe. Only a safe vehicle can be released on public roads. And this is very, very important to us at VVM. Okay. Now, what will you see today and tomorrow? We have some building blocks for our conference and the exhibition. What we try to do is we structured our methodology in 3 layers. The so-called capability layer. This is describing requirements, top goal, acceptance criteria, and the ODD. Then we have the engineering layer. The engineering layer is more or less that the system under test is exposed to controlled scenarios, and the real-world layer means that the system under test is exposed to uncontrolled scenarios. And do not get too nervous about the slide. There will be a lot of talks explaining these concepts to you throughout our sessions. And similarly, we have 3 other perspectives. We have the risk management perspective, we have the scenarios perspective, and we have the argumentation perspective. And using these 4 perspectives, we are trying to visualize, to explain, to tackle the challenges of safely driving autonomously in the open world. Yeah, and with that, I would like to thank you very much for your attention, and I wish you a great event and super discussions, and also enjoy the coffee in the coffee breaks.